do I download my topic? I don't think that's no.
If you can turn to page 14. We're going to use ratio tests to find the interval of convergence. We kind of know how to do this already since we introduced this before the quiz and before the test, and you guys actually did a variation of this. So today it's going to feel like we're just strengthening we're just practicing more of these types of problems. Oh, and also before I forget, admin really wants us to make sure that our doors are closed during instruction. So if you're coming in and out of the classroom, that's fine, but just make sure that you're always close to the door behind you. Okay, so page 14. So this is we call this a power series because this is a series that has a power of a variable, very much like kind of like where we're treating the x as a ratio of a series, and we're just continuing to multiply by a factor of that common ratio, but now the ratio is going to be like a variable. So this would be a power series. Yeah, and also it's a series that has basically this integer power here, or power that are going to be represented as integers. Since we're going to be raising that changing, ever-changing power to the next integer value. Now this is a power series that's centered at x equals 0. Meanwhile, this second one is also a power series, but this is now centered at a value that can be flexible. It doesn't have to be at 0. It can be centered at 2, it can be centered at 3. So this is centered at C. Okay, domain of a power series is the set of all x values for which the power series converge. That means the power series is going to actually exactly imitate the value of the series that is trying to mimic up to the exact value. So the center is always a part of the domain. Now, there are 3 ways that a power series may converge. The power series may converge to an interval. This is where the radius is the distance from the center to the edge of the interval. See if I can draw an example of this. So here's an example of, let's say the graph in black is the series in question, or the original series. And then let's say the power series is able to converge for an interval of values that it's able to be perfect up to a certain point, but then after it's going to start diverging. This we'll be able to say, okay, this series converges to this graph between this point and this point, right? So there's a certain radius, there's a certain interval that the power series can match to the graph. For other power series, some power series can converge to the graph for all real numbers, where it's going to be an exact replica. So, and then sometimes a power series can only converge to the center, meaning that, you know, it doesn't, it's not going to converge at all, except at one point, right? So there's three options. Either it looks exactly like it, it's matching for a range of values, or it's guaranteed to at least match at least one point. So a power series can at least do this. It can at least converge to the center, because that's not hard to do. But sometimes power series, sometimes this is the only thing that I can do, depending on what the graph is like. So we're just going to be determining that our interval of convergence is always one of these three answers. It's either infinity for all real numbers, it's for just one point, or it's for a range of values. Okay. So the interval of convergence is the set of values for convergence, where values are going to match exactly. We're going to use the ratio test to find the interval of convergence. And we're going to use power series to do that. So we're going to use ratio test to do that. Now, as we set up the conditions for ratio test, we're going to be interpreting things a little differently, okay, a little differently. So if I can show, because I'm basically going to be solving for x here. So whatever the limit of a sub n plus 1 over a sub n is less than 1, then the series will converge for a specific interval. All right, and we're going to have to, and this is what we saw on the test, where we had to test the endpoints and look to see, okay, are the endpoints going to be part of my interval? If my limit is equal to 0, then the series will converge for all values of x. We talked about how before, if we're doing a normal ratio test, if we get 0, we would say, oh, the test is inconclusive. But if we're using the power series or the rule for the power series to see if it converges, then equal 0 means it's perfect. That means it matches for all values. And if the limit goes to infinity, that means the series will converge only at the center. It diverges everywhere else. This is our power series is not going to be able to match the graph very well. It can only do it at one point. Okay, page 15. So we have a power series here. We want to know where is this power series going to converge? Where is this power series going to actually have an actual sum? So we're going to, for all these problems, we're going to use power series. So, sorry, ratio test. So limit as n approaches infinity of a sub n plus 1 over a sub n. And we're always going to see what this is equal to. And typically, if there's any x's left over, we're going to see if it's less than 1. So here's my a sub n plus 1. That means I'm replacing every n with n plus 1. Now, divided by my original a sub n, my original rule of sequence, the same thing as multiplying by the reciprocal. And let's just see if there's any x's left over. If there are x's left over, then we'll compare it with, we'll find the limit and see if is it equal to 1, less than 1, or greater than 1. Let me rearrange it so I can get all the n's together. So I'm going to start canceling a bunch of stuff out. X minus 5 to the n will cancel out. 3 to the n will cancel out. And here, my n approaches infinity of n plus 1 over n. What is this going to give me? Just what? Just 1, right? So the only thing left over is x minus 5 over 3. These are just static values, right? Or there's no more moving parts here. So x minus 5 is less than 3. This indicates that we're going to have a range of values. So we're going to set this to be less than 1. And we're going to find the range of values that this series is actually going to have a real number. So we'll set it up this way. Absolute value of x minus 5 over 3 is less than 1. I'm going to multiply that 3 over to the right side. So I'm going to have absolute value of x minus 5 is less than 3. There's something important that I want to show you about this form here. If you can get into this absolute value of x minus a number is less than another number, that's basically in this form of x minus c is less than r. Okay. This number will represent the radius, and this number is going to represent the center. Okay. So I think sometimes it's just good to know some of those features there. They're asking for the radius, you know that's going to be your radius. And if they're asking for the center, you know your center is going to be at 5. But we're trying to find the not only the radius, but also the interval of convergence. So the way we're going to move forward is we're going to get the absolute value to drop, and we'll do less than on both sides of the x minus 5, left side being -3 and the right side being 3. So we're going to say x minus 5 is between 3 and -3. Add 5 to all the terms. Now, this is your potential interval of convergence. You're guaranteed that the series will converge between 2 and 8. The only thing in question are what? We got to worry still about what? The endpoints. Yeah, so we got to test 2 and test 8. The way we test them is we insert them back into the original rule of sequence and see if 2 on its own will converge. If it converges, we'll have to include 2 as part of our interval of convergence. We'll put an equal sign. But if 2 does not converge, if it diverges, then we'll leave it alone. We'll leave it as just less than. And then we'll do the same thing with 8. Sorry, running out of room a little bit. Maybe I'll put on a separate sheet there. So let me test x equals 2 first. So all I'm doing is I'm just inserting 2 in for x and seeing if this resulting series will converge or diverge. Now, isn't this the same thing as -1 to the n times 3 to the n times n over 3 to the n? Right. If I have the same basis or the same exponents here, I can just merge it together. I can also separate it. And if I separate it like this, it's just easier for me to see, okay, all right, these are basically just going to cancel out. I'm just splitting that -3 to the n as -1 to the n times 3 to the n. And then -1 to the n times n, this n is in the numerator. This would fail by the nth term test, right? If n is approaching infinity, it doesn't matter. There's an alternate here. This n is going up to infinity. So this is diverges, right? So we would not include x equals 2. We know x equals 2 will diverge. Okay, so we'll test x equals 8. This will give me 3 to the n. The n's 3 to the n cancels out. I'm just left with n. So if I approach infinity, this will also fail the nth term test. This also diverges. So we would not include either of the endpoints. Both endpoints would diverge. So our radius is going to be 3, and our interval of convergence is just between 2 and 8. Okay, any questions? All right, so that's all we're doing today. We're just going to go through this process and just practice these types of problems. Okay, so try number 2. And then whenever they're asking to find radius and interval convergence, you're always just jumping to ratio tests. You don't have to worry about, oh, wait, maybe this one I got to do, I need to do geometric series test. This one I need to do comparison test. It's always going to be ratio test. The only thing that you have to do additional tests on at the endpoints. The endpoints, a lot of times the endpoints is like nth term or alternating series test. So even then, the endpoints only has kind of like a limited number of tests that's going to show up. So okay, so try number 2. I'll work through number 2 as you guys try it as well.
Is by how we put that limit of absolute value of x minus 2 is less than 1. So that is less than 1.
Right. So we're always just find the limit as n approaches infinity. If all the n's cancel out, then you know it's going to be a range of values. We're always going to be looking for values less than 1. If your n's don't cancel out and it just jumps to infinity, then we don't have to worry about it. It'll show you infinity on its own. Yeah.
Okay, so if the n's cancel, you say what?
That's right. Yeah. If all the n's cancel out, or this isn't 0 already, then it's less than 1. Yeah. So yeah. Yeah, because we haven't seen those examples quite yet. So I think when we get to 4 and 5, you're going to see what that looks like, and hopefully that'll make things more clear. Okay, so anytime I see that, I like to just remind myself what I'm looking at. That I know 1 is the radius, I know 2 is the center. And then I can start building my potential interval here. You're always going to have to make sure you test the endpoints. If I plug 1 in, I get -1 to the n. That's an alternator, but it doesn't quite fit into, because this gives us 3, then -3, then +3, then -3. So it kind of oscillates. It doesn't quite, and also the limit of this doesn't go to 0. So we know this doesn't pass the AST test. So we know this diverges. And then we know this diverges. There's no alternator here. I'm just doing 3 + 3 + 3 + 3. We know that diverges as well. So yeah.
Could we, that just because the answers in the numerator?
I think we should say that both of these diverges by nth term test, because the limit of this rule of sequence doesn't go to 0. Yeah, so I should be saying nth term for both. Oh, and then you don't have to be super descriptive in terms of showing all the steps, but once you test your endpoints, at least give me a reasoning of how you know that the series converge or diverge. So just say like nth term test or converges by AST, right? So you don't have to be as formal or as comprehensive as showing all your work from the previous quiz or previous test, but I do want you to tell me a brief reasoning how you know that the endpoint is converging or diverging. All right, any questions? All right, keep going. Number 3, try number 3. Yeah, again, if all your n's cancel out, you know that you're going to find the range of interval, and you're always going to set it less than 1. But if your n's do not cancel out, then it's either going to be infinity, which will be only converges at the center, or 0, which will be converges for all real numbers. So I know for right now, we've only seen problems where all the variable, all your n values just went away because of the limit. But we're about to see some problems where, what it would look like if your limit does, if we're not going to set it equal to or less than 1. Yeah, once you get into that x minus c is less than r, it's nice to see, okay, there's my radius, there's my center, and then I can get my interval built and then test my endpoints. Okay, try number 4. If you have no questions with 3, try number 4. Yeah, on my key, I forgot to indicate the reasoning, so we should be saying AST for both -1 and -3 as a reasoning for knowing that the series converge.
But, when you test x equals -1, it converges with AST. I thought the alternator is -1 to be.
Oh, sorry. No, you're right. Sorry, it does converge, but not by AST. This is going to be P series, right? Sorry, this one should be P series. Okay. For number 4, we're going to set up using ratio test. Replace all the n's with n+1. Multiply by its reciprocal. We can expand out our factorials. Bunch of stuff will cancel out, but not enough. There's more n's above than there is below. So this will go out to infinity. And there's a hidden center at x. If you just see x by itself, it's not x -4 or x -2. It's really x -0. So we know that the center is at 0. The radius is 0. Since so if we see infinity, that means this series does not converge anywhere except at the center. So because there's no range of values, my radius is 0. And in this case, my center is at 0 because there's no parentheses around the x. It's just x -0. Okay, so this is what it would look like if your series converges only at one point. It goes to infinity. Sorry, yeah, we're finding the radius of this this power series. This power series is not going to have any place where the series will converge except at x equals 0. If it's any other value, it's not going to come out to be a real sum. It's going to like the sum is going to be infinity. only at 0 is this sum of the series going to actually get us a real number. Oh, you mean if the limit goes to 0 here? If the limit goes to 0, then it will converge at 0 still. Sorry, the center is still at 0. But the radius will be negative to positive infinity because it would we would be able to get every point on the series to converge. Yeah. And we're going to see that in the next example. Okay, next example. So I think you'll be able to compare between 4 and 5 and see all the distinction between what things look like when you get a range of values, infinity, and 0. Over here, yeah. If I plug -1 in for x, I get -1 plus 2, which is 1. So 1 to the n plus 1 over n.
It's 1, and it's like 8.
Yeah, because 1 is not going to do anything. It's only -1 to the n is where that alternator is going to get into take its effect.
So to test for absolute convergence for the alternator, would we just test like if it was -1?
This problem is not asking for absolute convergence, but we would say this would converge absolutely, and this would also converge absolutely. Because if I were to take away, I mean, I know there's no alternative here, so basically, if I just found whether the series can converge on its own, this will converge on its own by P series. This will also converge on its own by P series. Yeah. Okay, number 5.
About series, just to clarify, it doesn't matter what's on the numerator, I guess. It just doesn't matter what's on the numerator as long as there's like an n to the on the bottom.
Yeah, this would, I mean, this is the same thing as 1 over n cubed, which would converge by P series.
Okay, so what's kind of like the general formula for P series is that 1 over n2?
Yeah, as long as my P value is greater than 1, it'll converge. But if it's between 0 and 1, it'll diverge. Yeah.
But then what if there's something else on the numerator, like I don't know, 2 to the n or something? Would you need to use a different test method?
Yeah, if it was 2 to the n over n cubed, I will use nth term and realize that this is going to fail by nth term. This will diverge.
Okay, so it's like related rates kind of.
It's like a comparative growth rates.
That's
Right.
Comparative growth rates. All right.
So I want you to look at number 5. Look at how when we do ratio test that the n is in the denominator. So this will go to 0. If this goes to 0, that means this series will converge everywhere. It doesn't matter what the x value is; it'll always converge. So this series converges for all values of x. Your radius is infinity, and your interval conversion is also all real numbers.
So looking at, what if the n factorial cancel out and leave n plus 1 in the denominator?
Oh, sorry, you're right. My bad. That's 1 over n plus 1. Our reasoning still stands, but yeah, that should be n plus 1. Sorry. There's still an n left over in the denominator. It'll still go to 0. All the reasoning is still right, but yeah, I canceled out the wrong thing. It's the n factorial that cancels it out. So what I want to say here between these 3 options is that you're not going to put a less than 1 unless all your n's are gone, right? If your n's are not gone, it'll give you either infinity or 0. You don't have to worry about, like when do I put a less than 1 for these scenarios? This will just automatically get to your result. But if you have x's left over, that means there is a range of values. So you want to find out, okay, what range of values will fulfill my conditions for convergence? So that's when you put that less than 1. Okay, let's just do one more. Oh, radius is infinity. Yeah, because it can extend
Yep.
indefinitely in both directions. Yeah. Okay, so page 16. Let's do one more, and then we'll be done.
You have to list the items here, can you just make them ready to draw?
For now, I just want you to have that structure of saying IOC, so that we have IOC for everything.
All right.
But I think down the road maybe we can get rid of that. But for now, let's just have that structure for now. Right, page 16, number 1. This will be the last one. Sorry?
Why can't we just leave it at less than 1 there? And so the action as well over the first instance.
There's a 4 that remains, so we need to bring that 4 over to get the true radius. So that's my radius, that's my center, and then from there I can filter down. Yeah, both -3 and 5 is going to diverge. That's nth term. It'll diverge by nth term test. The limit of my resulting series won't go to 0, won't approach 0. So
How do you know which side that one goes to? X minus 1.
it's -1. We're going to add it to both sides. So you want to get x by itself, and then add 1 to this side, add 1 to this side. So -4 plus 1 is -3, 4 plus 1 is 5. Any questions? So technically tomorrow is a virtual day or I know some of you guys are taking the ACT tomorrow. But the homework assignment is just for us to catch up to what we've done so far. So, I want to make it so that you're not having to do all the problems. So on page 3 through 17, we've covered these topics, sections for this new second part of Unit 10. So if you can look through page 3 through 17, mark those pages off. And every page, you're just going to do odd numbered problems. Okay? Just the odd number problems on pages 3 through 17. Okay, I'll send out a reminder tomorrow that I'll be checking these pages on Friday. And then, yeah, come get your phones. Yeah. Yes,
I can do it during fifth or tomorrow morning when more people are taking it, like whatever. It's fine.
You mean like Friday morning?
Yeah, Friday morning.
Okay, you can take it.
Oh, yeah.
But if you're not here Friday morning, you have to take it in class.
Yeah, I'll be here, so, thank you so much. This was a good one. I was a good one.
I won't do your Friday until the one. Oh, did I just like watch the recording?
Yes, let me also give you something. Is anyone not here? Is anyone not going to be here on Friday? Okay, I'm going to have you guys pick something up. You all, if other you guys want to pick something. Yes. The form those quiz on the Wednesday. So I want to make it also about. The quiz are those exactly like the problem will be a little bit from 5. Okay. But we're gonna have a quiz on
But I think and we
My goal is watch, my goal is.
That doesn't mean he's not watched, bro. That means he's not watched these videos too.
My goal been watched all of senior year. I guess in junior year.
This one. It's not so it's fun.
Yeah. The limit of simple. Yes.
I mean, the thing is, I think we don't have to do that.
It's still bad at, you know, fine. I cannot do it. We're not going to lie about it. I'm good at this. I'm good at art, so I'll play that after.
Like one. This is on previous. This is one.
I'm so stupid. I know he has a channel. Okay. Like
That's one, right?